Hey everyone, welcome back to my channel. I'm Chandan, and in today's video we are going to talk about something that every enterprise company uses, which is CI/CD, which stands for continuous integration and continuous delivery, or we call it continuous deployment. If you have ever wondered how companies like Netflix, Amazon, or Google they releases new feature without even breaking the old features and without breaking them, CI/CD is the secret behind it. By the end of the video, you will have a clear understanding of how CI/CD or how a pipeline works and how it is being used in a real enterprise environment. So let's get started. Before we dive into the CI/CD concept, let's take a step back and understand DevOps. DevOps is simply a culture. It's a way of working where the development team, the developers, and the operations team, which is the ops team, work together instead of working in silos. In traditional setup, what was happening is developer used to write the complete code and then they used to hand over to operations team to deploy and do the testing, which was causing delay. Because let's say they have developed let's say they deployed the application, and after deploying the application the operations team find that the particular feature is not working as expected, and by the time they will confirm this, it would be already sometimes that is gone, right? And when they go back to developer and give the feedback, developer might be working on some other project. Now for a developer to go back and verify with a, let's say, thousandth and thousandths line of code where exactly the issue is happening, that might take a longer time to fix those issues. That is where this new DevOps culture has come into, which is a continuous feedback system where every time developers write a code, it is being continuously pushed into the pipeline, and that is where DevOps bridges this gap by bringing automation, collaboration, and continuous feedback, making software development lifecycle faster and more reliable. If you look out at the picture which I am currently showing you, if you look out at this is the complete DevOps cycle, right? So what happens is, based on the plan, let's say as a company, if I'm planning to develop some application, so as a company we'll go ahead and plan it, we'll work on that, how the application has to be developed, and then it comes the code, right? Based on the complete plan, based on the strategy, the development team or the developer starts writing the code, and once the codes are written, it will be pushed and it will be built, compiled, and packaged. And once this compilation is done, it goes to the continuous testing. And from continuous testing, it goes to release. And then from the release, it goes to deploy. And from deploy, it goes to operate. And then post operation is the monitor. So this is, if you see, this is an infinity loop that happens, which shows a continuous feedback loop which developers gets at every stages. So even once he built a code and push it, and the particular code is getting uh, compiled or packaged, immediately he will get the feedback. So this is how the DevOps complete feedback loop cycle helps to make the software delivery much faster, much quicker if you'll compare it to any other stages. So let's first talk about the continuous integration. What is continuous integration, or CI? Imagine you are working on a particular project with 10 developers. Every developer is writing a code and pushing it to a shared repository or a version control system, which may be GitHub or maybe a GitLab. Now, once the developer writes the code and push this to a source version control system, which might be no GitHub, GitLab, or GitHub. Now, what happens is, if everyone working on different features, it's easy for code conflict or bugs to sneak in, and continuous integration helps fix it. What happens every time someone pushes the code, let's say developer pushes the code, the CI process automatically initiate. This is the build process, and the CI process automatically build the application, and then it goes ahead and automatically build the application and run the tests to check everything still works fine. If there is an issue, let's say a test fails, so if it is going after the build, the artifacts are getting generated, and if we are seeing any kind of issues, automatically what happens, there is a test fail happen or a build is break and the builds fail, automatically the system notifies developers. It goes and do a continuous feedback and it informs developer, and they can go ahead and easily fix it, because what they have just pushed it is a small line of code. It's not a complete line of code. Whatever the small features they are working, they go ahead, do the coding, do the development and push it immediately. And that is where that whatever the new changes is there, it is easy for developers to recognize, and even if it fails, they can easily fix it. For example, in many enterprises, if you'll see tools like Jenkins, if you see this is the Jenkins icon. So tools like Jenkins, GitLab CI, uh, you have Azure DevOps and Circle CI is also which are used for CI. They automatically triggers a pipeline when a new code is committed. So there will be webhook which would be configured. So what happens anytime a developers push a new line of code to GitHub or GitLab, any source version control system, automatically the CI will trigger. And that's initiate the compiling and packaging part of the software. So if you look out at this phase, right, starting from starting from this developers write the code, it get pushed to the source version control system, it goes ahead and then compile the package, and then that package is being tested, which is the unit test stage. This is the stage where like unit tests are done and integration tests are done, along with sometimes we run the security scan like sonar scan and all to ensure new changes did not break anything and everything is working as expected. My application is working as expected, there is no issue. In case there are any issues which are detected, automatically there will be a continuous feedback that will be given to the developers to fix these issues on regular basis. So starting from developer writes the code till the testing, where it is till the unit test cases and all, this is what we call it, which is called CI state, so which is a continuous integration. So from developers writes a code till this process where the unit test cases are done and all, and gets completed. This is the stage which is called CI. Now, once the CI is built and tested in CI stage, what happens? Once those tests, once the CI is built and tested, what happens? Once the code is built and tested, the next step is the CD. And CD is what which is meant continuous delivery or the continuous deployment. Now, many people gets confused between the difference. What is the difference between continuous delivery and continuous deployment? Let's understand the difference. Continuous delivery means the code is automatically built, tested, and ready for deployment. But the deployment to production is done manually after approval. So there will be an approval stage. Once the deployment has to be done and the code is ready to be deployed to the production, there would be an approval process that should be followed, and then only it can go ahead and deploy to the prod. So that is called continuous delivery. Now, when it comes to continuous deployment, what happens? Continuous deployment goes one step further. The code automatically gets deployed to the production after passing all tests and checks. So whatever the stages that is enabled as part of the continuous CI/CD process, the continuous deployment goes ahead, and without any manual steps, it goes ahead and deploy the application to the production. In enterprise, most teams prefers continuous delivery. The reason is they wanted to have a final approval or change window before releasing anything, the new features to the production. Now, let's look at the typical CI/CD pipeline. This is the heart of the system, right? So when I was talking about this, right, this is the source code stage. Everything starts when a developer goes ahead, commit codes to a version control system like GitHub, GitLab, or it could be Bitbucket. Now, once the codes are pushed based on the webhook which is configured, which we'll understand in the later stage of the videos. In another video, I'll explain it in complete detail. So what happens is, once the webhook, based on the webhook configurations, what happens once the code is pushed, the code automatically triggers the build stage. So the build stage can be done using the tools like Bamboo, like Jenkins, GitHub Actions. So during the build stage, what happens during the build stage? During the build stage, the code is compiled or built. For example, if it's a Java, Maven, even if it is a Java application, Maven or Gradle tools might be used to package it into a deployable artifact like .jar or .var file. Now, post this artifact is generated. That is where the test stage comes in. Automated tests are run during this stage: unit test, integration testing, and sometimes, as we were I explained earlier, that security scan using SonarQube to make sure the new code changes did not break anything. Now, once this stage is done, post that comes the deploy stage, where the code is deployed to prod, QA, UAT, and prod. So normally what happens during the deployment stage, there are tools which can be used like Argo CD. We have Dockers, Kubernetes, that could be that is where that they would be part of the infra where this your code or your application will be deployed. So as part of the process, what happens once the test pass, the pipeline automatically deploys the build to a QA or a staging environment where QA team can perform the regression testing. So there could be a stages or there could be environment you have where you do first the progression testing, or then it goes to the another environment where you do the end-to-end regression testing. So this is the place. Once the regression testing and everything is done, the environment is certified, sanity check has been done. That is where you can go ahead and push it to the prod. Now you can, once the code is deployed, there are different tools as I was speaking, the tools like Kubernetes, Docker, Ansible, Terraform. This can be used to go ahead and deploy your application to the prod. Now, once the code is live, once your application is running in production, you can go ahead and you can have monitoring and alerting system like Prometheus, Grafana. They can be used to monitor the performance of the application, and they continuously give the feedback how the complete application is working, what is the user feedback, and based on that there is a continuous feedback that runs and it goes to the developers, and developers, based on this continuous feedback loop, developers can go ahead and make changes to the app in case there are any issues reported, and that is how it goes ahead and works. So any enterprise diagram or in any real world enterprise environment, CI/CD pipelines are part of larger ecosystem. So code moves through multiple environment. So from dev, it moves to QA, from QA to UAT, and from UAT to prod. Each environment may have its own approval steps and automated checks. So this is what we are talking about, an enterprise environment. Pipelines are often managed using Jenkins shared libraries. So when we will learn about Jenkins tools in much more deeper concept, then I'll talk about the Jenkins shared libraries or GitHub template to ensure consistency across hundreds of applications. There could be security check and compliance. Gits are added, like you could use secure SonarQube to do the static code analysis. You can use Black Duck and Fortify to do the vulnerability scan, and to make sure whatever is being deployed to the prod, there should be no any issues reported post the codes are moved to production. The entire process helps organization deploy frequently with confidence, reducing manual efforts, downtime, and human error. Now, let's quickly talk about the benefit of CI/CD. Now, this is the complete process. Now, what is the benefits of using CI/CD as a part of DevOps? First, It can help you in faster delivery of the software. Features reach customer very quickly. It can help you in early bug detection. So issues are caught right after the code is pushed. Since even as small changes which the developer is pushing to the source control system, everything is built and complied, unit tests are done. So at any point of time, issues are caught right after the code is committed or code is pushed. Now, third is better collaboration. Developers, testers, operations teams works in collaboration to ensure the SDLC lifecycle, which is software development lifecycle, is much quicker and it is seamless. Fourth, it helps in improving the quality. Automated testing ensures stable releases. You will not get bug, you will not get no issues reported from the customer. Fifth is the reduced risk. So once you have a CI/CD pipeline, it also have features like rollbacks. In case there are some issues based on your monitoring feedback, you can go ahead and roll back. So let's say there is a feature that has been pushed and the users are getting impacted because maybe a few of the features are not working as expected. Immediately you can do the rollback to the previous version. So we will talk about much more deeper concept how the rollback works in any production environment, how it is being handled, and how seamlessly it helps enterprise organization to roll back in case of any uh, issues which are reported at a larger scale. So that's the essence of CI/CD in DevOps, a combination of automation, collaboration, and continuous improvement. If you are someone who wants to get into DevOps, understanding CI/CD is your big or first biggest steps. So in the upcoming videos, I'll walk you through the real CI/CD pipeline demo using Jenkins, GitLab. So don't forget to subscribe, Tech Ventures, and hit the bell icon. Thanks for watching. I'm Chandan. I'll see you in the next one.